Let's do another example, another word problem that gives us a quadratic equation. Let's say we have a beautiful square. So it's a 1 by 1 square, whatever the units are. It could be inches, it could be feet, it could be meters, just as long as we keep things the same throughout, that's fine. So this is 1, 1, 1. This is going to be 1. But what I'm going to do is I'm going to tack on a rectangle here, just so it fits perfectly. So for it to fit, that has to be 1 and that has to be 1. But this is going to be, I don't know. I don't know what that is. Now, here's what I want. I want to know what value of x makes the two rectangles, so not the original square, but this rectangle and the giant rectangle, proportional. Some of you might say, hey, wait a second, there's not 2, there's actually 3, because even though not every rectangle is a square, every square is a rectangle, well, I don't care about the original square. What I want is I want this rectangle to be proportional to this rectangle. And what do I mean by proportional? Well, I don't mean that this is the same size as this. Obviously, it can't be the same size because this is smaller. It's inside. But, well, unless this was stretched all the way, which it isn't. But what I want is I want the ratios of the length to the width. So I want this length over this width to be this long length over this width. Okay, so, and I need to know what value of x would have the property that this rectangle, and this is what this is telling me, is if I took this, I turned it on its side, and I blew it up perfectly, just magnifying it, not changing the ratio, it would fit perfectly there. Okay, so what do I need? I need this length over this width, 1 over x, equals this long length over this width, 1 plus x over 1. And this is the equation I need to solve. Okay, well, what could I do? I could try to get rid of all the fractions first. That's not a bad idea. This on the left equals this on the right. So if I multiply them both by x, what do I get? I get this. Or this gives me, okay, on the right I have x squared plus x, and I subtract this 1 over to the right. This is the quadratic I need to solve. Well, how am I going to solve it? I could try to factor. I don't have a lot of hopes for that, right? Because I need to have like an x, a 1, and a 1. And there's no way I can take plus or minus 1 and plus or minus 1 and get plus or minus 1 when I combine them, regardless of whether I add or subtract. So, let's try either completing the square or the quadratic equation. Maybe let's try completing the square. So this is the equation I have that I wish to solve. This 0 equals x squared plus x minus 1. So, what's my a? My a would be 1, but I don't care about that. I know that b equals 1. I want to take b over 2 because I'm completing the square, and b over 2 squared, which is 1/4. So that's going to give me, for this, I take x squared plus x plus, this is the thing I add and subtract, so I get plus 1/4 minus 1/4 minus 1, and I'm setting that whole thing to 0. When I regroup, these three terms are going to give me x plus b over 2 squared, and then this is going to be minus 1/4 minus 4/4. So that's what I get. Okay. So, now I want to solve this. All I need to do is move that 5/4 over to the right, use my rule for radicals, so this is plus or minus the root of 5/4, and I get x is equal to minus 1/2 plus or minus the root of 5/4. And some of you are saying, probably already, well, I could do something with the square root of 4. Absolutely. This is root 5 over root 4. And I could sort of just combine these. Now don't get scared about me moving this plus or minus into the top. Basically, I have minus 1 divided by 2, and either plus or minus root 5 divided by 2. So that's just going to be the minus 1 plus or minus root 5 divided by 2. I can look at this in many different ways. I could pull out a 1/2, or I could just think of it the way I just described. Okay, and you might say, oh no, I don't know what the answer is because we got two answers. But think about it. From our picture, should we allow x to be negative? Absolutely not. I'm not allowing this to go into the square like that in this direction. I want to toss that idea out. I want to have something that matches this picture. I specifically said we were going to tack it on onto the side of the square, so this has to be a positive value. So, if I need a positive value, which do I choose? Well, if I take minus 1 minus root 5 over 2, that is negative, so I'm going to cross this out and get x is equal to minus 1 plus root 5 over 2. This is a very, very famous number. It's called the golden ratio. And it has many important properties, including being the limit of sequential, or the ratios of the Fibonacci sequence, which is a sequence that appears in lots and lots of popular movies. Tom Hanks talks about it in the Da Vinci Code. If you do a quick search for movies containing the Fibonacci sequence, there are just tons of them. It's one of those things that lots of people like to use. People talk a lot about this appearing in art and architecture and lots of different musical pieces as well. This ratio is used in different ways. But that is a nice little example of completing the square in order to solve a different type, a very geometric, but different type of word problem, which turns out to be a quadratic equation.